And then the stuff we go over today, it's going to be very short. It's just going to be that way, basically that way we don't have to do it when we get back from break. We're going to do it while it's still fresh in our minds. It's very dark in here. I'm sorry that if my screen looks really dark, this room just doesn't have good lighting today. Anyway. 6.3. Dropping things. All right, so we are going to talk about graphing exponential functions today. So, sorry, getting organized here. So, graphing exponential functions. An exponential function is a function in the form y equals a b to the x, where a and b, guys, a and b are just numbers. They're just numbers. Y is a y, though. X is an x. A and B are numbers. Here, just like two examples of what this could maybe look like. Y equals 2 and then times 5 to the x. This is an example of an exponential function. Or y equals negative 1/2 to the x. These are both examples of what exponential functions look like. Really, the thing to look for is that, like, if you're trying to decide, is this an exponential function or not? Do you guys see how your variable is actually your exponent? That's what really tells you that this is what's called an exponential function. So if you guys looked at the stuff I posted on Tuesday, you might remember that exponential functions either increase or decrease rapidly. Okay, so they either increase, go up really, really rapidly, or they decrease, go down really, really rapidly. Bailey, you got to start charging your computer before class, bud. So the independent variable, which is x, increases or decreases by a constant amount. And the dependent variable, or y, is multiplied by a constant number. So, well, actually multiplied or divided, maybe add that down there, or divided. Do you guys remember when we decided if a function was linear or not? Like when I gave you guys the table and we would count and be like, oh, okay, each x goes up by 2, so that's constant. Each y goes down by 3, so that's constant. So it's a linear function because it has a constant rate of change. Looking at exponential functions, it's a similar idea for it. The x's are going to always increase or decrease by the same amount, but then the y's get multiplied. And the way to kind of remember that they get multiplied is if your numbers are getting big really, really fast, they're getting multiplied because that's how you get numbers really big, right? Think about like adding versus multiplying. If I multiply 6 times 6, it's 36, but if I just add it, it's just 12, right? Multiplying gives you bigger numbers. So as far as what an exponential function looks like, we're dealing with a curved graph like this. This is actually an example of exponential growth. If you looked at the stuff on Tuesday, it starts down low and increases really quickly. Where like a linear function is just a line. It's doing the same thing the whole time, right? It's increasing or decreasing by the same amount. So what we're going to do is practice just deciding, is something a linear function or not based on a table. So we're going to look at our x values, see how they change each time. Look at your y values, see how they change each time. So if you take a look at number 1 here, our x's are 0, 1, 2, and 3, and our y's are 2, 4, 6, and 8. So let's take a look at our x's and see how they change each time. So if you take a look, the x's are doing what? Are they going up or going down each time? Yep, they're going up by 1 each time, so that's constant. So at this point, it could still be either linear or exponential because that kind of depends now on the y's. So now if you look at the y's, what are our y's doing each time? Going up by 2 each time. So in this, they were both just going up the same amount each time. They're not being multiplied or divided by anything, right? It's just adding the same amount each time. So this one's actually linear. So if I had to choose between linear or exponential, this is an example of linear because it has a constant rate of change. So we're going to say linear, constant rate of change. Okay. All right, now let's look at number 2. So somebody else, take a look at the x's. What are the x's doing each time? Going up by 1. Okay, so my x's are constant. What about my y's? How do you get from 4 to 8? Oh, Aiden already told us. Aiden says they're being multiplied by 2 each time. That's exactly right. If you take 4 times 2, it's 8. 8 times 2 is 16. 16 times 2 is 32. So these were being multiplied by 2. So this time, I don't want my x's to accidentally look like plus signs. So this time, if we're multiplying our y's, would this one be linear or exponential? Definitely exponential. So we're going to say exponential. And we're going to say that's because the y's are multiplied by 2. Good. Sorry, my handwriting is particularly bad today for some reason. All right, and then number 3. Looks like the x's are just doing the same thing, so we just won't even worry about that. Those are going up by 1 each time. All right, and then what's happening with my y's? I have 8, then 4, then 2, then 1. They are going down, yeah. But they go down, like if you think adding or subtracting, right? It goes down by 4, and then by 2, and then by 1. So, you know, that wouldn't be constant. Is there something I could divide each one by? By 2, right? What's 8 divided by 2? 4. What's 4 divided by 2? 2. What's 2 divided by 2? 1. So this one would actually be, see how my numbers are getting smaller? This one would be exponential decay because it's getting smaller. So here, we're dividing by 2 each time. Good. So this one is also exponential. Because the y's are divided by 2. Good. Okay. So the next thing we're going to do is, since we're going to need to do some graphing, we're going to need to know how to find points for our graph, which means we're going to need to know how to plug things in to equations that look like this. So we're just going to practice that really quick. If you have a calculator, please get one out. You will have to, you can't do this in your head. You're going to need a calculator for it. So grab a calculator out, use the one on your phone. If you have one of these, great. Use the one on your computer, I don't care. But I'm going to show you how to plug this into your calculator. Okay, so evaluate each function for the given value of x. So we have y equals -2 times 5 to the x. So remember, when there's parentheses and there's no sign in between, that means multiply. So this is saying to evaluate this when x is 3. So I'm going to plug 3 in for my x. So let me write what this would look like. So we're going to solve for y, and we're going to do -2 times 5 to the third power. Okay. Now, there's two different ways you can plug this into your calculator. First thing is we can think about order of operations. When you do order of operations, what goes first? Parentheses. If you look inside the parentheses, there's nothing inside them, right? But then after parentheses, don't you have exponents? And isn't there an exponent? So you could do the exponent part first. So let me show you this way first, and then I'll show you the other way. So if you do the exponent, and I think I showed you guys how to do this the other week, but if you have one of these calculators, remember your little up caret button? It's under the pi symbol. Do you see that button? That's how you can do an exponent in this calculator. So you would hit 5, and then your little up caret, like the little top of the roof house up arrow kind of button, and then 3. And you should get 125. Do we see this? Yes or no, ladies and gentlemen? Okay. Annalise and Hayden tell me that they see it. What about the people who do not have their cameras on? Do we see how to do an exponent in this calculator? Okay, perfect. Okay, so that's that part. But then don't I still need to multiply by 2? So don't clear out your calculator or anything, just then hit times 2 or times -2. I'm sorry, what was that, hon? Yes, thank you. Yeah, -2. So you should get -250, like this. Okay, so you should get that y equals -250. Now I'm also going to show you a way to plug this all into your calculator at once if you prefer. When you have like parentheses like this, you can actually plug this in exactly like this into your calculator. So the other way you could do it is -2 comes first, so you to put your -2 in with the small negative sign, not the subtraction. Then in parentheses, put 5, just like it's written in your problem like this. Do we see this? And then put your little exponent sign, your little up caret like that, and then put 3. And then this is literally written the exact same way as it's written on your paper, except, I mean, you have to have the little like up caret part, right? And then you can hit enter, and it'll do it for you all at once. When you guys look at it, is it backwards or is it correct? It's correct, okay, because when I see it like up in my little corner of my screen, it's backwards, so I wasn't sure how it looked for you guys. Right? No, the iPhone does not. Let me see how you would do it on your iPhone. That's fine. Okay, so the iPhone, instead of the caret, do you see the little, there's on the second, once you turn it into scientific notation, like the scientific calculator, see the second row of things? There's something that says x squared. You could use that to square things. The x third you can use to cube things. And then if you have to do like a fourth power or a fifth power or some weird power, you can use the one that's x to the y. So what you do to do that, Annalise, so on the iPhone, you can't plug it in all at once, really. So what you'll need to do on the iPhone is you'd hit your 5 first, and then your x to the third button, and it'll automatically give you the 125. And then do times and then 2 negative. You have to hit the 2 first, then the negative. I know it's weird. Equals, and then you'll get your 120. Yeah, you're welcome. And if you need to do a weird exponent, Annalise, like we're gonna have like we're gonna have to use an exponent of like -2. So if you want to do that, you'll use the y, the x to the y button. So to do something like that, let's say it was, you'd hit your 5 again, right? And then you'd hit your little x to the y button. And then you'd hit 2 negative and then equals. And you should get 0.04 like this. Yeah. Okay, cool. It's not as nice just because you have to like do things in a kind of a weird order. But it still works. Actually, we'll get to practice that on this one because we have a negative exponent here. Okay, so if we go over to number 2, we have y equals 3 to the 0.5, or 3 times 0.5 to the x. So I'll show you on both calculators. We would have y equals 3 times 0.5, and then my exponent is -2. Okay. So on this calculator, I would probably plug it in all at once if this is the calculator you have. I would hit my 3, parentheses, 0.05, like this. Okay, so if this is the or not 0.05, I'm sorry. 3 parentheses, 0.5, like this. Sorry, my bad. Okay. Then I'd put my little exponent button, my little caret, and then -2. Okay, so if you have one of these calculators like we use in class, this is how I would plug this in. And then hit enter, and you should get 12. If we're using one of these calculators, do we see this? Yes or no? Okay, thank you, Asia. I need to hear from other people too, because you're gonna have to plug numbers in on your quiz, and I need to know that we know how to do this. So can I hear some yeses or nos, or I need helps from some people? Okay. Anyone else? Who all is using this kind of calculator? Jake, you said you have one of these, right? Okay, so you think you're good with plugging this in? Okay, Aaron, what kind of calculator are you using? Your phone? Okay, so we'll go. Do you have an iPhone? Okay, we'll go over that next. Corey, what kind of calculator are you using? Corey, what kind of calculator are you using? Oh God. Jesse, what kind of calculator are you using? Your phone? Do you have an iPhone? Okay, we'll go to that one in a second. Kason, what kind of calculator are you using? Phone, okay. Aiden, what about you? Don't know. Okay, Olivia, what kind of calculator are you using? Hannah, what kind of calculator are you using? Thank you, Hannah. Who else? I'm literally going to go through and ask every single person because half the people aren't answering me. Mason, what kind of calculator are you using? Okay, well, hopefully the people who didn't answer me know what they're doing. Let's go through it on the iPhone calculator. Maybe Corey's having some microphone issues because he just left, so maybe he'll be back. Okay, so if you're using the iPhone, again, make sure it's turned in scientific form. Okay, and what you're going to have to do with the iPhone calculator is put the part in parentheses in first. So you'd do 0.5 like this. Okay, then there's no option in your second row for an exponent of -2. So you're going to have to use the X to the Y button. So click the X to the Y button like this. Then you're going to have to plug in an exponent of -2. So you have to click 2 and then the plus minus button that's up next to the C. So then it should look, then you should see your -2. Then hit equals and you should get 4. And then you would do your times 3 to get 12. So if you're using the iPhone calculator, you got to do this part first and then multiply by 3. Corey, you back? Were you having some microphone issues? If we're using the iPhone calculator, were we able to figure that out? Perfect. Okay, cool. And we'll have some more practice with it today because we'll be graphing it. But just wanted to make sure before, so we're not like trying to figure out how to do it while we're also learning how to graph. I figured we'd try that first. Okay. I don't know how to fix this, but my Microsoft Word is doing this weird thing where my pages aren't separated. I don't know why. All right. Anyway, so exponential functions. We're going to have our a term, our b term to the x. So there's two different types. Sorry that this is kind of spaced weird. Sorry. Okay. So we can have two different types of exponential functions. We can, first of all, have something called exponential growth. That is when our function starts down really low and then increases rapidly. So our graph is going to increase quickly when our b value, that's our value in parentheses, is greater than 1. Okay, so an example of what that could look like is maybe y equals 1/2 3 to the x. This would be an example of exponential growth because our number that's being raised to the x power is greater than 1. We can also have exponential decay, and that is where our graph decreases quickly. So it starts, our values start up high and then they decrease quickly. The little bottom here is cut off, but there should be graph right there. So for example, when that happens, when our b value is between 0 and 1, so numbers like 1/3, 1/2, 1/4, things like that. So if you see something like y equals 2 times 1/3 x, this 1/3 here, since that's the number being raised to the x power, since that's between 0 and 1, this would be decay. But honestly, if you can see the graph, you'll be able to tell whether it's growth or decay. So what we're going to do is just practice graphing some of these. So we just have 6 graphs to try out, and then we'll be done. And hopefully then we can start on our homework. So we are going to graph the exponential function, and we're going to state if it is growth or decay. I know in each one of these I have 5 boxes. We're just going to graph 3 points though. Okay, so especially because we're not in person, we're just going to do 3 points instead of 5. And to keep our life simple, we're going to pick the same 3 points every single time. We are always going to plug in -2, 0, and 2. And that's just to keep our life easy, to make sure we have a reasonable curve in our graph, and all that stuff. So -2, 0, and 2. So here is what we are going to do. We're plugging in a value, right? So this number is going to get plugged in where you see x. So these numbers that I wrote down, the -2, 0, and 2, these are going to become our exponents. So when I plug in -2, I'm going to do 2 to the -2. So you're going to plug 2 to, sorry, this isn't working right. You're going to plug 2 to the -2, into your calculators. Okay. So you're plugging in 2 to the negative 2. So if you're using one of these, and it doesn't really matter with this if you use parentheses or not because there's no parentheses written. So you do 2, your caret button, negative 2, like this, if you're using this calculator. Okay. So you should get 0.25. If you're using the iPhone, then what you're going to do, so I almost dropped my phone, is you're going to hit your 2 and then your X to the Y button, and then hit your 2 and your minus sign. And you should get 0.25 as well. Was anyone not able to get 0.25 when they plugged it into their calculator? Annalise, you weren't? Did you? You forgot the negative sign then. Yes. Okay. Yeah. You got to use the little gray, the little light gray plus minus that's up here next to the C. Yes, you do have to use that one. Make sure. And guys, make sure you're practicing this. If you are just relying on me to do this, you are not going to know how to do it on the quiz tomorrow. And there is literally a chart on your quiz like this that you are going to have to type in the number. So you're going to have to know how to use your calculator. So please practice this. I don't care what calculator you use. I can even go through how to, okay, perfect. I can even go through how to use the one that's on your computer if you want. Is anyone using their computer calculator? Bailey, what calculator are you using? Are you using a phone or are you using one of these? Phone or one of these? Phone, okay. We have, yes, Hannah, if you go down to your search tab at the bottom of your calculator, or I'm sorry, if you go down to the search tab at the bottom of your computer, there's like a little blank space that says type here to search. If you search in calculator, your computer does have a calculator. I can show you how to use that too later if you want. I just have to share my whole screen instead of just this part. Okay, so I'll do that on the next part here. So then if you then plug in 0, so you're going to have 2 to the 0 equals, so again, in your calculators, do your 2 caret 0 like this, or on your iPhone or whatever your scientific phone calculator is, do your 2, and then your X to the Y button, and then plug in 0, and then somebody tell me what they got. Exactly. Yep, you should absolutely get one. That is correct. And then you're going to plug in 2. Now, some of these you might be able to do without your calculator. For example, what's 2 squared? 4. So like that one, you know, if you want to plug it into your calculator, you can, but it's just 2 squared, which is 2 times 2. Okay, now let's graph this and see what it looks like. So, as far as graphing this goes, if you have a really, isn't like 0.25 a pretty small decimal? Yeah. So what you're going to have to do if you have a pretty small decimal to work with is you're going to put your dot really close to 0. Okay. So if you're at -2, so your coordinate point here is -2 and then 0.25. So same idea. And I guess too, like since you're just going to be graphing at -2, 0, and 2, right? -2 is here, 0 is here, 2 is here. So for your first one, if you're at -2 and then 0.25, you're just going to go right above this -2 like that. And then 0, 1 would be right here. Right, so it would have to go 1, then 2. And then 2, 4, like this. And can you guys kind of see how your graph is starting to curve upward? Now we're not graphing a lot of points just to like make our lives a little bit simpler, but here's what I need you to do. You need to connect those points, but you need to extend it out a little bit in front, and then you need to continue to extend it up. So it should look something like this. Okay. Try to obviously draw a nicer curve than I did. It's hard to on this thing. There we go. Something like that. Okay, because you need to show that it continues upward and put your little arrows on it. Do we see how to kind of graph that? All right, perfect. All right, so now let's check out number 2. Number 2, we have 1/2 x. Now, 1/2 fractions. But can you rewrite 1/2 in a way where it'll be a little easier to plug into our calculators? How could we rewrite 1/2 in a way that it's a little easier? Yeah, I would change it into 0.5, exactly. Or 0.5, doesn't matter, Hayden. But yeah, I would probably change it into 0.5 to the x. That makes it a little easier to plug into our calculators. And we're still going to plug in -2, 0, and 2. All right, so, and with this one, we only have the one number, so you don't have to use your parentheses if you don't want to. They put parentheses on this because it was a fraction, okay? But since it's just the one number, you can drop the parentheses if you want. So we're going to have 0.5 to the -2. We're going to plug that into our calculators. So on the iPhone calculator, because I feel like that's what most of us are using, do your 0.5, okay? Then your X to the Y button, this guy here. And then to plug in a -2, you're going to have to click the 2 and then the plus minus sign that's up at the top next to the C. And then hit equals, and you guys should get 4. Perfect. Was everyone else able to get 4? Or did anyone not get 4? Okay. All right. Now plug in your 0. So we'll have 0.5 to the 0. Who can tell me what they get for that once they plug that in? Yep, that would be 1. Very good. And then plug in 2. So 0.5 squared. Yep. Very good. Okay, so now let's graph this. Okay, so this time, this is actually kind of the opposite of the one we just did. We have -2 and then 4. So at -2, go up 4 and put a dot. So right here. At 0, go up to 1. And then at 2.25, just a little bit above. Now this one, it's curving the other direction. Okay, so we want this is actually exponential decay. We want our graph to start up high and then go down low like this. And that's actually something I forgot that I want to make sure we can recognize is you're going to need to, I forgot about this part of the directions, state if growth or decay. So remember, growth starts down low, grows up high, decay starts up high, goes down low. So was number 1 growth or decay? Growth. Make sure you write this down because you'll have to identify this on the quiz. Was number 2 growth or decay? Decay. Good. All right. Questions about 1 or 2? Okay. All right, number 3. We got 3 to the x. So we're going to plug in -2, 0, and 2. So we're going to practice using our calculators. So we should have 3 to the -2. 3 to the -2. Practice plugging it in, and I'd like to hear what we got. Not from Hayden or Annalise, though, just because I know that they've practiced using it. So from somebody else. No offense. I just know that you guys tried it out because you've already told me. So somebody tell me what you get. You're going to get kind of a weird decimal. Anybody? Asia, what'd you get when you plugged it in? You there, Asia? Aaron, what'd you get when you plugged it in? Yeah, you're good. Yeah, that's exactly what you should get. Yes, 0.1, and then the ones go on forever. So here's what we're gonna do. We're just gonna round that to 0.1. And guess what that is? That's just a really small decimal. So that's just gonna go right above 0. Okay, so that's really each one of them is probably gonna have something like that. Just something that's a really small decimal. All right, now let's plug in 0. So 3 to the 0. Take second, plug it in. And then Mr. Sanders, tell me what you get for 3 to the 0. You there, Jake? Maybe we all left when I was changing my graphs. Uh-huh. I did call on you. We're just plugging this in. So Hannah, which part are you having trouble plugging it in? Okay. Are you using an iPhone calculator or a school calculator? Okay. iPhone. Okay. So on your iPhone, Hannah, what you'll need to do, so I'm assuming you probably had trouble with the -2 part. So first, plug in your 3, okay? Then you need to hit your XY button like this, because that's what's going to tell you to put in a different exponent. Then you need to click 2. And then you need to click your plus minus sign that's up next to the C, because that's going to change it to a -2. And then hit enter down at the bottom. Okay, did those steps work for you, Hannah? Okay, perfect. It would be, yep. And that's actually going to always happen. I don't know if you guys have noticed that. Anything to the raise to the 0 is always 1. So that's why that's happening. And then if you have 3 squared, somebody else, what do you get for 3 squared? 9. Good. Okay. So put a dot at -2, we're at 0.1. So again, that's just a really small decimal. So just go right above it. And then 0, we're at 1. And then at 2, we're all the way up here at 9. So remember, 9 would be between 8 and 10. So this graph went up a little bit higher. So connect your curve, right, and make sure it keeps going upward, and also make sure you continue it a little bit to the left as well. So would this be exponential growth or decay? Very good, it would be growth because it is going up. Ladies and gentlemen, do we understand the difference? How to tell if it's growth or decay? Okay. All right. So let's try out number 4 then. So for number 4, we have 1/4. Again, that's a fraction. Let's try to not plug fractions into our calculators. Anyone know how I can change 1/4 to make it a little easier to plug into the calculator? Yeah, that's what I would do. So 0.25 to the x is what we're going to change this into. Good. And you don't have to have the parentheses if you don't want. They just put them because it's a fraction. So we're going to plug in -2, 0, and 2. So you're going to do 0.25 to the -2 first. So again, if you're using your iPhone calculator, be careful here. You're going to click your 0.25 and then your X to the Y button. And then click your 2, then your plus minus, then equals. And somebody tell me what you guys got. Very good, 16. Hannah, were you able to get 16 for this one? Okay, perfect. Now plug in your 0, so 0.25 to the 0. Let's see. It is still going to equal 1. Good. And then 0.25 squared. Aaron, were you able to figure out 0.25 squared? No. Are you having calculator issues or have you just not done it yet? That's fair. Okay, what do you think? Yep. Look, it should look something like this. And that's, again, there's just a really small decimal, right? So that's going to be our point that goes right above 0. I'm just going to write 0.06. I'm just going to kind of chop off the last part of that fraction. So I'm going to put 0.06. Were we able to get that number? Okay. All right. So at -2, we have 16. So -2, go all the way up to 16, all the way up here. Bailey, are you getting these numbers when you try it out? Okay. Are you practicing it in a calculator or a phone? Okay. Perfect. Okay, so then at 0, you should get 1. And then at 2, it's 0.06. So that's going to be our thing that's just right above the 2. Okay, and then connect this the best you can with your curve. I didn't do a great job, so I'm going to redo mine. This is, yes, we are starting way up high and then going way down low. This would definitely be decay. Good. Okay. Any questions on this so far? Jake, did you ever come back? I don't know. Jesse, have you been able to plug these into your calculator? Yeah, Jake, I called on you before and you didn't answer. I was just calling on you again to see if you were able to plug these into your calculator. Okay, okay. And Jesse, it was working out for you as well? Okay, cool. Brooklyn, are you doing okay with the calculator? I'm not sure who all I haven't checked on yet. Oh yeah, we're gonna do the rest of them. We'll have time. I'm just trying to see. I don't know. People aren't really answering me. Okay. All right. All right, so numbers 5 and 6, you'll see are a little different just because we got the two numbers, okay? So here's what you're gonna do. If you're using an iPhone calculator, do the 4 at the end. This just means multiply by 4 at the very end. So we are going to plug in same things we've been plugging in, -2, 0, and 2. So we're gonna have 4 and then 2 to the -2 like this. So here's how you're gonna do this in your calculator. You're gonna first just do 2 to the -2. So do your 2, your x to the y, and then put in your exponent of -2. And you should get 0.25. Then this just means times 4. So you're just gonna then multiply by 4. And you should get 1. Okay? So you should get 1. If you plug this into one of our school calculators, like the ones we use at school, you can do this all at once. And you can do 4 parentheses, -2. I'm sorry, not -2. 4 parentheses 2, like this. And then your little caret -2. Okay, so like that. And you should still get the same thing. Now do 0. So 4 and then 2 to the 0. So do the exact same process. So do 2 to the 0. So 2 to the 0, that should give you 1, right? And then times 4 should give you what? 4. And then plug in 2. So 4 times 2 squared. Okay, so do your 2 squared. So 2 squared, you should get 4. And then multiply that by 4, and you should get what? 16, exactly. So at -2, put a dot at 1. At 0, put a dot at 4. And at 2, put a dot up at 16. And then connect. And you'll see this one's a little bit steeper. Sorry, my screen is glitching out in the middle there. So, somebody I haven't heard from yet, or haven't heard from as much, would this be growth or decay? Growth, good. Okay. And then last one. We have 3 and then 1/2 x. So we're going to change that 1/2 into a 0.5. So we're instead going to do 3 and then 0.5 or 0.5 to the x like this. And I'm going to plug in -2, 0, and 2 again. All right. So we're going to first do 3 and then 0.5 to the -2. So in your calculator, plug in your 0.5, right? Then hit your XY button, and then 2, and then your plus minus, right? So you're basically doing this part first, which we We actually already did this up in number 2. Huh? It would be 12, yes. So you're going to do this part first that I circled, and then multiply that by 3. So 4 times 3 would give you 12. Okay, we good with that? Okay. And then plug in your 0. 3 times 0.5 to the 0. So 0.5 to the 0, right? That's going to give you 1. And then 1 times 3, you should get what? 3. Oh my God, yay. Okay. And then plug in your 2. We're going to have 3 times 0.5 squared. So plug in your 0.5 squared. Do your 0.5 and then square it, and you should get 0.25. Did we get that part? Okay. And then multiply that by 3, and you should get 0.75. Okay. Yes. You didn't? Let's see. Yeah, redo it once, and then we'll see what happened. So what are you getting? You're forgetting to then multiply it by 3 at the end. Oh, okay. So yeah, so you should do 0.5 squared, and 0.5 squared should get you 0.25. And then you need to still multiply by 3. So then once you multiply by 3 and hit equals, you should get 0.75. Okay. Okay. That's what was happening. Makes sense. Okay, so at -2, put a dot up at 12, 0, 3, and then 2.75 right below. Okay, so 0.75, I would just put that right below 1, or again, it's a decimal. It's a small decimal, right? Less than 1. So just put it a little bit above and then connect your curve. And what do we think, folks? Exponential growth or decay? Definitely decay. Good.